All right, so let's dive into something kind of interesting today. The whole vaccine shedding thing with the mRNA COVID vaccines.
Okay.
You've probably seen this topic online, maybe even thought, oh, that's misinformation. But we're going to actually look at the science here, pulling from research, like infectious diseases research, and get this, documents from Pfizer's own trials.
Hmm.
Yeah. So the question is, could components of these vaccines, or like the spike protein they make in your body, could those be passed from someone who's vaccinated to the people around them?
Right.
So let's find out.
I'm ready. Let's dig in.
Okay.
It's important to approach this with a critical eye, and really understand what's going on here, like the mechanisms
Right.
at play.
So first, like setting the stage, right? Vaccine shedding is a real thing.
Yeah.
But like traditionally that was about vaccines using a weakened live virus, like the MMR vaccine.
Right.
With those, there's a chance that little bits of that virus could be shed. That's not what's happening with mRNA vaccines, right?
Exactly. Yeah, think of it this way. With live vaccines, it's like sharing a slightly runny nose, like you might pass on a little bit of the actual virus.
Uh-huh.
But mRNA vaccines are more like sharing a recipe.
Oh,
It's the ingredients or what those ingredients create that we're looking at here.
okay. That's a helpful analogy.
Yeah.
So with mRNA, we're talking about three main players, right? Those lipid nanoparticles, the LNPs, they
Right.
deliver the mRNA, then the mRNA itself, and then the spike protein that our body makes from those instructions.
Yeah.
And here's where it gets interesting. Pfizer's own phase 3 trial documents mention the possibility of exposure to the vaccine just from like breathing it in or skin contact.
Wow.
They even talk about potential impacts on like pregnancy and breastfeeding, which wasn't exactly front page news, was it?
No, not really. And that raises some questions about, where do these vaccine components go in the body and for how long?
Right.
What we
Yeah.
call biodistribution.
Biodistribution sounds complicated.
Not really. It just means, where these components travel and accumulate in the body. Think of your lymphatic system like a network of highways for your immune system.
Okay.
That's where these nanoparticles travel, ending up in places like your liver and your spleen. And research shows they can be detected in blood plasma for up to 2 weeks after vaccination, which is longer than we initially thought.
So they hang around for a bit.
They do.
But most of the research that's been done on like shedding has looked at urine and feces, right?
Right.
What about other ways these things could get out, like sweat, saliva, breast milk, even things like semen? I mean, Pfizer's documents were clearly a little bit worried about breast milk.
Yeah.
So they must have considered these other things.
That's a really good point, and it leads us to something called extracellular vesicles, or EVs.
Okay.
Our cells, they naturally produce these tiny nanoparticles. They're like little mail carriers, traveling between your cells, delivering messages. And guess what? They're found in all sorts of bodily fluids.
Oh, really? So like if I'm sweating after my workout and EVs are in sweat, could vaccine mRNA be leaving my body that way? Some people say they sweat more after getting vaccinated. Is that even possible?
Well, we know that EVs in sweat can contain nucleic acids, even full-length mRNA, so it's a question worth asking.
Yeah,
Definitely need more research to say for sure.
makes sense. Now, what about the spike protein itself?
Right.
That's the whole point of the vaccine, right?
Yeah.
Our bodies learn to recognize it and fight it off, but what happens to it afterwards? Does it just disappear?
Not necessarily. Studies show it can persist in the body for weeks, sometimes even months. And get this, it can get packaged up inside those EVs we were talking about,
Oh, wow.
potentially extending its reach within the body. There was even a study where they found vaccine spike protein in the skin cells of a patient with shingles 3 months after they were vaccinated.
3 months.
Yeah.
That really challenges the idea that it vanishes quickly.
It does.
And shingles, that's a completely different virus. It makes you wonder about the long-term effects.
Yeah, it does raise some questions, and that's where the research into how scientists are using similar nanoparticles for other purposes gets really fascinating.
Okay, I'm all ears. What do you mean other purposes?
Well, scientists are using LNPs and EEs as delivery systems for medications.
Oh, okay.
They're like these tiny targeted packages,
Uh-huh.
can carry medicine to very specific parts of the body. And what's remarkable is they've been used successfully to deliver drugs through the skin, through inhalation, even intranasally, to target the brain.
Hold on, you're saying these nanoparticles can deliver things through the skin and like through the air.
Yeah.
That makes this whole shedding thing seem a lot more plausible, doesn't it?
It does.
Especially since Pfizer themselves mentioned those possibilities.
It does lend credence to the idea. There's even research showing that plant-derived nanovesicles, which are functionally similar to our own EVs, can deliver RNA across the skin and even into tumors.
Wow, so these things are like microscopic delivery trucks. That's both amazing and a little bit unsettling when you think about, you know, vaccine components hitching a ride.
Right.
But let's get back to the research on shedding. Specifically, what have scientists actually found?
All right, so let's look at some specific studies.
Okay.
One that really dives deep into potential excretion routes is by Helene Bannon. It was published in Infectious Diseases Research.
Okay, what did Bannon find? Was there any evidence of these vaccine components actually being shed?
Well, interestingly, Bannon points out that the regulations for gene therapies, which technically include mRNA vaccines, actually require studies on the excretion of these products.
Huh.
But guess what? Those studies weren't done for the COVID-19 mRNA vaccines.
So there's like a regulatory gap here. It's not like nobody thought about shedding, it just wasn't thoroughly investigated.
Right.
That's a little concerning, isn't it?
It does raise some eyebrows.
Yeah.
Bannon even highlights a section in Pfizer's Phase 3 trial protocol, specifically mentioning concerns about the vaccine potentially being transmitted through breathing it in skin contact semen and breast milk.
So they knew it was a possibility, but didn't fully explore it.
That's right. The document even mentions that a pregnant woman could be exposed to the vaccine through environmental exposure from someone who's been vaccinated. It's right there in black and white.
I can see why this is a big deal for people.
Yeah.
Okay, so what about the research that has been done? Have any studies actually found evidence of shedding?
Yes, there have been a few. One study published in NPJ Now, Vaccines, looked at the presence of vaccine mRNA in breast milk, and they found detectable levels in a small number of women who were vaccinated.
Okay, so it's not just theoretical. There's actual evidence of vaccine mRNA in breast milk. What does that mean for breastfeeding infants?
That's a question that needs further study.
Yeah.
Another study published in JAMA Pediatrics also found vaccine mRNA in breast milk. And what's even more interesting is they found the mRNA concentrated in those extracellular vesicles we were talking about earlier.
Those tiny mail carriers.
Yeah.
So they're not just delivering messages between cells. They could be carrying vaccine mRNA from a vaccinated person to someone else?
Potentially, yes. It suggests that EVs could be a vehicle for shedding. And remember, EVs are found in all sorts of bodily fluids, sweat, saliva, semen. We exchange those fluids with others all the time.
That's a sobering thought.
Yeah.
Okay, so we have some evidence of shedding in breast milk, but what about those other potential routes? Any studies on those?
Not really, but there's another piece of evidence that's pretty intriguing, even though it wasn't directly looking at shedding.
Huh.
It's a case study published in Pathogens about a patient who developed shingles 3 months after getting the Pfizer vaccine.
Shingles. That's a completely different virus. What does that have to do with vaccine shedding?
Well, researchers found vaccine spike protein in the patient's skin cells 3 months after vaccination.
Wow, 3 months. It's a long time.
Yeah.
It supports what we were talking about earlier, that the spike protein can persist in the body for a while, but what does this have to do with shedding?
It doesn't directly prove shedding, but it does raise some questions. The authors of the study suggest that this long-term persistence of the spike protein could have implications for the immune system. And remember, the spike protein can be packaged into those EVs, which can travel throughout the body and potentially be shed.
So we have evidence of shedding in breast milk, a case study showing the spike protein hanging out in the body for months, and a whole lot of unknowns about other shedding routes. It definitely seems like there's more to the story than we initially thought.
There's certainly more to uncover, and then there's this other study that wasn't even designed to look at shedding, but it might actually provide some indirect support for the idea.
Okay, I'm intrigued. What study is this? Okay, lay it on me. What study is this?
So this study was published in Pediatric Research, and it compared two groups of unvaccinated children.
Okay.
One group was living with unvaccinated parents. The other group lived with vaccinated parents.
Interesting setup. So two groups of unvaccinated kids, one exposed to vaccinated parents, the other not. What did they find?
They found that the children living with vaccinated parents had detectable levels of anti-COVID EG antibodies in their noses. And the difference was statistically significant compared to the kids with unvaccinated parents.
So the unvaccinated kids living with vaccinated parents had antibodies against COVID even though they weren't vaccinated themselves?
Exactly. Now, the authors of the study, they concluded that this was due to antibody shedding, meaning the antibodies themselves were being passed from the vaccinated parents to their children.
So not shedding of the vaccine components, but shedding of the antibodies produced because of the vaccine. That's still pretty wild, though.
It is, however, Bannon, in her research paper, suggests a different interpretation.
Okay.
She proposes that maybe those kids developed antibodies not from like direct exposure to their parents' antibodies, but because they were exposed to other vaccine byproducts, perhaps those LNPs or other components being shed by the parents.
Oh, that's a whole other level. So their immune systems might have been responding to the vaccine components themselves, not just passively receiving antibodies.
It's exactly. It's an intriguing possibility. Well, we need more research to confirm this. It does make you think about the potential for vaccine shedding to trigger an immune response in those exposed strands.
Okay, so we've covered a lot of ground here. It seems like there's a real possibility that shedding is happening, but there are still a lot of unanswered questions. Where do we go from here?
I think the biggest takeaway is that we need more research. We need to know the extent of shedding, the possible ways it happens, and the long-term health implications. This is especially important with mRNA technology being used in more and more vaccines.
Right, and it's not about being pro or anti-vaccine.
Right.
It's about being pro-science and pro-informed choice. People deserve to have all the information when making decisions about their health.
Absolutely. And we need open and honest communication from health authorities and researchers.
That's what we try to do here on the Deep Dive.
Yeah,
We're not telling you what to think, but giving you the information you need to form your own conclusions.
exactly. We need to keep asking questions, demanding evidence, and holding those in power accountable.
Well said. So for all our listeners out there, what can they do besides, listening to amazing podcasts like this one?
Stay curious and stay informed. Look into the research yourself. Ask your healthcare providers questions. Talk to your friends and family about this. The more we talk about these important issues, the more we can push for transparency and better research.
Great advice. And that's a wrap on our deep dive into mRNA vaccine shedding. We hope you found this insightful and maybe even a little bit thought-provoking.
If you'd like to explore further, we've included links to all the research we discussed in the show notes.
Thanks for joining us, and until next time, keep asking those tough questions.